Presenters, your 3 minutes begin as soon as you begin speaking. The timekeeper will be in the front of the stage to your left, over here. If you exceed 3 minutes, and please don't, the timer will sound and you will be disqualified. I hope we don't hear that sound tonight. Is that the sound? We will now begin with our master's student, our first master's finalist. May I have the next slide? Is Richard Lee from Interactive Computing on EarBit, using wearable sensors to detect eating episodes in unconstrained environments. Richard.
Chronic diseases such as diabetes, breast cancer, and obesity have been shown to be linked to dietary habits. Physicians often prescribe food journaling, which is recording what we eat, as a way of stimulating reflection about our own dietary habits, such as what we eat and how much we eat. The problem with food journaling is that there's very, very low adherence. We forget about it as soon as we're the next day. We attempt to address this issue through through proposing a wearable device that will prompt you to remember to journal what you eat. So the problem that we're trying to address is when we eat, and not how much we eat or what we eat. We simply prompt the user when we detect when they eat so that they can reflect about these details. We began development of the device by assessing 3 sensors that are conducive to everyday use and are very practical for wearing. The first sensor is a motion sensor placed behind the ear, looking at ear motions because the ear is connected to the jaw. So if you put your finger behind your ear and you move your jaw, you can actually feel a muscle moving, and so we're looking at that motion. The next sensor we're looking at is a depth sensor. So we put a depth sensor inside the ear to look at the ear canal movements. So if you put your finger inside your ear and you move your jaw, you can feel a similar motion. Finally, we also put a microphone near the chest to listen for swallowing and chewing sounds. What we found was that the motion sensor behind the ear was actually sufficient by itself to accurately detect chewing, and our user surveys agreed that this was the best approach in terms of both appearance and in comfort. Now that we finalized the design of the device, we evaluated it in the real world. We gave the device to 10 participants and asked them to go about their normal daily lives. Over the 10 participants and over 24 hours of data, we saw 2-minute snacks, 30-minute meals, sporadic munching on popcorn during a movie, and in total there were 16 of these eating events. We were able to identify 15 of these eating events, and we only false triggered twice. We also took a closer look at the data, showing that looking at how quickly we respond to the beginning of the eating event, and we showed that we were only delayed by 1 minute from this time the user began eating. In addition, we were able to capture 75% of the time that the users were eating, indicating roughly how much they were eating. Since validating the accuracy of our device, we've been taking this further and further investigating what kind of behavioral changes we can instill in people, hopefully leading to a healthier world. Thank you.